Guys, in this video I'm gonna teach you how to perform binary search. Now this is a program written in C, and I'll first start with the header file which is #include_stdio.h, and now this contains library functions, namely printf and scanf. Those functions are defined in the #include directive, and then I'll start from the main function. So the main function is the basic block of a C program from which program execution starts. And so first let us understand the concept behind binary search. So let us take an array of some n elements. So you want to search for a particular element in the array. The conventional method you adopt is you'll traverse through the array to find out the element if it's present at what position. So that is very tedious, and also it's time consuming. So the other process, the better one which is employed, is the binary search. Now this works on the principle of divide and rule. So you divide the array into two parts, and take the first half and search for the element. If it's not found, take the second half, and if it's found, then again divide the second half into other two halves. So in this way the process goes on until the required element which you want is found out in the array. So this method is quite easier, and also the number of traverses, or you can say the number of ways in which you access the element, is reduced. So first I'll start with entering the array. So the array is defined here, or I can say I've entered some elements into the array, and then the element that I want to search, I will enter that. So now I'll take two variables, start and end. Now these are used to traverse through the array for searching any element. So initially when the array is considered as a full, then I'll take start equals 0 and equal to the last element. So the mid value is given by start plus n by 2. Now this loop is the execution part of the binary search, and here I'll take first of all, if item is directly found in the middle, then I can directly print the value of the item which is present at that position. So the condition is checked prior to the execution of the binary search, so there is no need to execute all these statements if the element is directly found at the middle. So if it's not found in the middle, then I'll go through these set of statements, and also the other condition to satisfy is start is less than or equal to n. And what does this signify? So an element present anywhere in the array should always lies between start and end. You see this condition. So if start greater than end, then there is no way that element can be found, because the element present anywhere in the array should lie between start and end. So now this condition is useful to find whether any element is present in the array or not. Sorry, the element that you want to search is present in the array or not. So after verifying these conditions, then I have to check whether the element is present in the first half of the array or in second half. So I'll use an if condition. Suppose that if it's present in the second half, so then I have to change the parameter start and end. Now start points to the value which is just, or it points to the position just after the middle position, or so I'll write it as start equal middle plus 1. So if it is found in the first half, then I'll execute the else block, where the start remains same but n value changes, so which is given by middle minus 1. Now at any time either of these conditions is satisfied, and so depending on the start and end values, I can write the middle value as start plus n by 2. So now this is repeated until these conditions prevail. So when these conditions fail, then the element is found at the middle value, so which is given by middle plus 1. So the middle denotes the array index, and now so that is a system index, and according to user index, so it is middle plus 1. So if item is found at the middle, then I'll print the position. So if the condition fails, then if start is greater than end, then I'll print that the element is not found in the array. That's how binary search is done.